Bismillahirrahmanirrahim. Assalamu alaikum and good morning to my students. So today's day is the maths day. So we were doing probability, and is there any chance that I will be delivering lecture on physics today? Yes, this is your homework, and you will find the probability that I'll be delivering the lecture on physics as well today or not. Okay. Now we were doing probability. Our topic was continued with the probability. So we were doing theoretical probability, I hope. And you know that I've already drawn a dice on the whiteboard. And there, there are six faces on the uh, dice. And each face is uh, dedicated to a number. Each phase is dedicated to a number 1 to from 1 to 6. Okay, and now you see when you roll the dice, it is an equal chance of equal chance of any phase will show up. Now these phases are not considered, only the uppermost phase is considered. So e- each number or each phase has an equal chance of coming up. And if I desire that I want a 6 out of the 6 positions, then there is again the probability that 1 by 6 is the probability that 6, there are 6 faces and only one can appear. So there is only 1 out of 6 chance that 6 will appear on the above on the dice. Okay, let us continue. Let me tell about you what is biased and what is biased. In probability, these two terms are do have a very significant position. If on, for example, this dice is uh, given due treatment, there is some tempering done on this dice. Okay, for example, any corner has been rounded and rest of is not rounded, then the die is said to be the biased. Okay, now let me explain to you about the biasing and unbiasing of any thing which we consider for probability. For example, my my what I collected the data should be unbiased. It should not be given due consideration that he is my relative, he is my nephew, she is my niece. So this should not be considered in probability. And if we are playing even with the die, the die should be unbiased. How it can be unbiased? That when you take it from the market, you don't have to uh, trim its ends from a special position that only six will appear. It will make it biased. It will make it biased. If you had trimmed it, for example, you have trimmed it from here and made it round. For example, this is not for real. We have made it round from here. When you roll the dice, it is more probability that this face will roll more than the sharp corners, because this is round. So the die has become biased. The die has become biased. Similarly, what I told you, that the biased result should not appear in statistics or in mathematics. The biased result should not appear. We have to we have to take an unbiased die. And for example, I want now I want there's a my desire is to collect the even numbers. The even numbers. Now The even numbers are how many there are even numbers. Now this is the even number, this is the even number, and this is the even number. Okay. Now how many possibilities are there for the even number? There are three possibilities for the even numbers. Okay. And how many total outcomes for an unbiased die should be there? There are six outcomes. There are how many? There are six outcomes. So my desired number of the even numbers divided by total number. Now how many even numbers are there? There are three even numbers. There are three even numbers. 1, 2, 3 even numbers, and total outcome is 6. Therefore, my probability will remain 1 by 2. There is 50% chance, 1 by 2 or 50% chance that an even number will appear on the above on the face of the die. Okay. Now, I hope you would have understood. Now, I can write it. I can write this same. I can write the same like this PA. Now A is what? A is the even number that I want, that this is the desired number. Okay, is equal to the favorable outcomes. Is the number of favorable outcome. Is the number of favorable favorable outcomes divided by number of total outcomes. Okay, so this is the what we call it theoretical probability. Now, if the die or the coin was biased, if the die or coin was biased, then we cannot say that this is an equally likely event. Then it is not to be said that it is equally likely event, because the coin, the thing from which we are going to experiment is already biased. It has already been touched. It has been already been touched uh, in that has been imperfectly touched, and something wrong has been done with it. Something wrong has been done with it. So the results are no longer unbiased. So the thing on which we are going to experiment should be unbiased. Okay. Now there is an example coming up. An unbiased die is thrown and number of upward face is recorded. Find the probability of obtaining three even number and a prime number. So there is again, let me, I have written this formula or uh, the relation. So there is a question that if an unbiased die is thrown, I want to know that a 3 will appear on the face. Now, what is my probability? What is my desired result? That is 3. Probability is 3. So I put here 3. So because my desire was here, my desire was the even number. Oh, in my example, previous example. Now my desire is only 3 should come. So how many? Number one thing, that the dice is unbiased. Remember this point. How many threes are there? There is only one 3. You see that there is only one 3. So there is only one chance out of 6 chances that 3 will come. Now the number of favorable outcome is only one. Only one. And the number of total outcomes is 6. So there is a probability of 3 showing up its face is 1 by 6. Okay. Now the B is that it should be even. I have already done for the even number and for the prime number. Now for the prime number. Let me do it for the prime number. Now how many prime numbers are there in a dice up to 6? Now of course there are 6 faces on the. Now, 1 is prime number. Is 1 prime number? No, 1 is not the prime number. This is not the prime number. 2 is prime number. 3 is prime number. And 4, no, it is an even number. And 5 and 6, yes, 5 is also prime number. So, how many prime numbers are there? There are 1, 2, 3 prime numbers. 1 is not the prime number. I have told you in my very first chapter that very first lecture that 1 is not the prime number. 2 is the prime number, 3 is prime number, and 5 is the prime number. So there are 3 outcomes, 3 favorable outcomes. So it is equal to, let me do it in proper way. Probability P, or you can say PR, that both should not mix together, is 3 upon 6, that is equal to 1 upon 2 again. Okay, 1 upon 2. So this is the result over here. Now there is another example. A card is drawn from ordinary 52 pack. What is the probability the card is the king? Now you might have seen the playing cards. There are 52 cards in one deck. There are 52 cards in one deck. How many cards? There are 52 cards in one deck. Plus there are also 2 jokers. But jokers are not always played. In some playing methods, the 2 jokers are used. Otherwise, uh, 52 are the cards, and in 52 there are 4 colors. In 52 cards there are 4 colors. The colors are black, red, black, red. Okay, there are 4 colors. You have been wondering that I have written black, red, black, red. These are 2 colors. But let me go forward. Okay, now black is the spades. Spades. Red are hearts. Okay, blacks are black spades, red heart, and black uh, clubs, and red diamond. The shape of the things are like this. If I can make it properly, I have never played the cards. Okay, this is the spade. The heart is red. The heart is red. Black club is like this. And diamond, red diamond is like this. Okay. In now in these colors, 52 colors, 4 colors, black spade, red heart, black club, red diamond. There are 13 cards each. There are 13 cards each. Now there are 13 cards. And from 1 to 10, from 1 to 10 are the numerical cards. From 1 to 10 are the numerical card. For example, number 1 card is like this. It has a only one spade or whatsoever it has, like this. This is one spade over here. Okay, and similarly in 2 there are 2, 3 there are 3, 4, 5 up till 10. But from 10, after 10, from 11 to 13, these are pictorial cards. These are not numerical cards. These are the pictorial cards. How the pictorial cards? number 1, number 11. Number 11 is the Jack, J, okay. Number 12 is for 12. It is Queen, and number 13 is King. Okay, it is King. These are pictorial cards, and a picture is also made on this King, Queen, and J, Jack. Okay, now there are 13 cards, 13 cards of each color, and in each there are 10 numerical cards and 3 pictorial cards. Now, what is our question? The question is, a card is drawn from 52 card pack. What is the probability that card will be a king? Now, how many cards are there? There are 52 cards. Okay, and in 52 cards there are 4 colors, and in 4 colors, how many kings are there? How many kings are there? Of course, each color contain one king. Each color contain one king, because these are 13 cards, these are 13 cards, these are 13 cards, these are 13 cards. In each there is from 1 to 10, from 1 to 10 numerical cards, from 11 to 13 pictorial cards, and in pictorial card each have one king in it. Each have one king in it. Now if I shuffle the cards, and say you to pick one card, then what is the probability that it would have been a king? Now, how many kings are there? There are 4 kings. One king relates to this, one king relates this, one king, one king. Okay. How many kings are there? There are 4 kings. So number of favorable outcome is 4. The number of favorable outcome is equal to 4, and PK, I can say it. PK, the probability of king is 4, and how many cards are there? There are 52 cards. Now this is the probability, and the final probability should be this, that it will be 1 by 13, 1 by 13th probability that the king will be picked by someone. Okay, now you have noticed that how I explained it. Now another example. Now there is another example. Jason has 20 socks in a drawer. 20 pairs, that means 20 pairs of socks. Okay, Jason has 20 pair of socks in a drawer. 8 socks are red, 10 are blue, 2 are green. Okay, if sock is drawn at random, what is the probability that is it green? Now, how many pair of socks he has? Jason has, now let me write the data. Jason has 20 pairs of socks. This is socks, and sometimes it is also written as like this. This is wrong, this is right. Okay, 20 pair of socks. Now, out of 20 pair, the colors are 8 socks are red, 8 are red, 8 are red, and 10 are how many? What are the 10? 10 socks are blue. 10 socks are blue, and 2 socks, yes, only 2 are left, are green. Yes, and if I draw one sock, one pair of socks from the drawer at random. And what is at random? That I don't know what is coming up at random. I don't know. It is at random, just by chance. I draw with my closed eyes, or I am looking at my mobile, watching my mobile, and I draw a pair of socks. What is the probability? What is the probability that it is green? that it is the pair is green. Okay. So how many the number of favorable outcomes? Now, if I draw green at random, there are two possibilities only. There are how many possibilities? There are two possibilities because from the 20 pairs, there is only two pairs green. There are two pairs are green, so that PG is equal to PG is equal to two possible outcomes are there. Two number favorable outcomes are there or possible outcomes are there, and how many possibilities are in total is equal to 20. That means 1 by 10. 1 by 10 is the probability that the pair of green will be picked up. Okay, now there are a lot of examples. Let me do because in probability, the more you work upon the probability, the more you learn. So I am not going to skip any example from here. So after that, I'll be doing exercise 8.1 Hollywood. HOLLY Hollywood. Hollywood, you are very much familiar with Hollywood. Okay, you might have seen its movies and maybe the state in which the Hollywood is created. Okay, Hollywood. And now we have some probability questions with the Hollywood. Okay, nine painters are assigned a letter from Hollywood for painting at random. Find the probability that painter is assigned the Y letter, A, the letter O, the letter H, or the letter L, the letter Z. Okay, there are four questions. And out of four questions, I am not concerned who painted it and who is going to paint it and who are the painters. So nine painters were assigned. In fact, how many painters were assigned this job? Nine painters were. I am concerned with how many painters are there. Nine. Nine. Okay. This is nine. Nine. Nine painters. Nine painters were assigned to do this job and they painted this Hollywood because it is very large. So nine painters were assigned to do this job. Okay, Hollywood. Now, number question A is what is the probability that the painter what is the probability that painter is assigned a letter Y? Painter is assigned a letter Y. Okay. How many painters are there? There are nine painters. And how many Ys are there? Is this Y? No, no, no. Yes. No, 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 no. There is only one Y out. Okay. There is only one Y. So probability of Y. So probability of painting a Y is 1. And how many painters are there? There are nine painters. So that means only one painter had a chance to paint Y. Okay, this is the probability out of nine painters. Now, what is the best question B? B is the letter O. The letter O. So there is 1, 2, 3. So PO is equal to 3 upon 9, that is equal to 1 upon 3. Okay, and similarly the other questions are there and it is and yes, one letter, the D. What is the probability that painter has painted letter Z in the Hollywood? In the word Hollywood. Now this is quoted. Now is there any letter in this Hollywood? Is the letter Z there or not? Yes, there is zero letters. There is zero Z letters. So zero painters will be assigned to do this job because the letter Z does not exist here. The letter Z or Z does not exist here. So there is no chance that any painter will be assigned with letter Z to be painted in the Hollywood. Okay. Now let me proceed. Now the probability of not happening. I've already given you a touch of it. A probability of not happening. Probability of not happening. Probability of not happening. Okay. The probability of not happening, event not happening, is that if there is a probability, that is one. For example, if there is a probability of 1, and now I told you in my previous lecture of probability that there are two possibilities. For example, that it will rain, that it will rain today, and the opposite to it is that it will not rain. Okay, it will not rain. So the probability of raining or not raining. There are two probabilities that it will rain today or it will not rain today. So the collective of two is one probability. Collective of two is total one probability. That means the probability of raining is, for example, yes, if it is rain, it will not it will rain, it will not rain. Is there are two events, so there is 1/2 events. It will rain or it will not rain. But what if I say it will not rain? PNR, not rain. So it is, what I will write is 1 minus 1/2. 1 minus 1/2. Because my subject is this at the time. This is my subject. This is my subject. It will rain today. Now let me just erase this. Okay, this is my subject. It will rain today. Okay, and when I say that it will rain today, this is my subject. And of course, if it has not rained today, then the probability will be like this. And you see that the total probability will remain as 1. The total probability will remain as 1. Now, for example, the probability of that Jasmine passes her driving test is 2/3. What is the probability that Jasmine fails? Now, for example, a lady, Jasmine, is going to driving license authority, and there is 2/3%, 2/3 probability. There is 2/3 probability that she will pass the driving test. Now I have been given the probability. Now this Jasmine is going to attempt a driving test. So there is a probability that she will pass the driving test is 2/3. But what if she does not pass the driving test? Now it is simple that probability Jasmine not passing is equal to P. This is P, and 1 minus 2/3 is our probability that she will not pass. And of course it will become as 1/3 when you solve it. Now not passing, the probability of not passing is 1 by 3, and which was given was 2 by 3. So collectively if you see that 2 by 3 plus 1 by 3 will be 1. Okay, the topic is over, and exercise is coming up ahead of us is 8.1. So mm, should I proceed with the exercise? Yes, I can proceed. Maybe lecture is a little longer or lengthy. Don't be afraid. No question. Exercise 8.1. Exercise 8.1. Question number 1. A simple die is thrown 100 times and number 5 appears 14 times. Find the experimental probability by throwing a 5, giving your answer fraction to its lowest term. Okay, very easy. Now let me, whenever you are given the question in anything, maybe in physics, in chemistry or mathematics, statistics, just write it data what is given to you. Okay, what is given to me is dice is thrown. A die is thrown 100 times. Thrown 100 times. It is thrown 100 times. Okay, and what else is given? And number 5 appears 14 times. 5 number appears. 5 number appears 14 times. Okay. Find the experimental probability of throwing a 5 giving your answer. Now you see that the favorable outcome in this case, because it is all given, it's not so 14, 14, and the total outcomes were 100. So what is the probability? What is the probability of 5? What is the probability of 5 is equal to 14 divided by 100. 14 divided by 100. So he has also asked to make it to the simplest fraction. So 7 divided by 50 is our simplest fraction of the probability that 5 has appeared in this game of 100 times throwing a die 100 times. Rolling a die for 100 times. 7 by 50 is the each chance of coming 5. Now a diagram is, let me reproduce the diagram first, then I'll. Now my dear students, a table is given. Statistics and the probability questions are tabulated sometimes. So a table is given in which a number is given and frequency is given. I've already told you that what is frequency. Now frequency is the number of events that are occurring again and again. For example, if this uh, there is, what is this? Let me write it. Diagram shows that spinner is divided in exactly here. Okay. Now there is a toy. There is a toy or uh, something like this. An octagonal figure is there. You know what is octagon? It is an eight-sided figure. One, two, three, four. Yes, it is eight-sided. And umbrella division is given on this. Do you know what is umbrella division? Umbrella division is from center to the sides. Okay, this is umbrella division. This is called umbrella division. And there is a pointer over here. There is a pointer over here, and 1, 2, 3, 4, 5, 6, 7, 8 are numbers. And if I spin this umbrella or whatsoever it is with 8 divisions, now what is the chance that 1 will come, 2 will come, 3 will come, 4 will come, 5 will come? Okay, it is all given in this. Okay, it is all given here, and the given are 33 and 38, 96, 38, 26, 35, 39, and again 21, 33, 35. Now the table is complete. Now you see that 1 has appeared 33 times, 4 35 times, 6 21, and 8 35 times. Spin the coin. Now if I add these frequencies, the total number of spins will come. The total number of tries will come. Okay, the total number of spins will come. The total number of spins are 260. The total number of spins are how many? 360. Total number of spins. Spins total is equal to 260. Now what is the our question is the number 3 will appear. Now first of all we are given number 3. We are given number 3. Now the probability of 3 showing up here by the spin. Now what is the probability that 3 will appear? Now what is the probability that 3 will appear? Now for 3 will we see that how many possible outcomes were there? The calculated outcomes were 26. The calculated outcomes were 26. 26 out of 260. Now these 26 was the frequency that whenever I spin up till 260, the total number of 3 was appeared 26 times and the total number of spins were 260. Then it has become, now this 26 1 times and 10 times, okay, it is 1 by 10. Now similarly there are the factor of 8. It is an interesting thing, a factor of 8. I have just skipped 2. You can do it by yourself. Factor of 8. Factor of 8. You know the factors of 8. If you uh, remember my lectures, the factor of anything is 1. For example, we have taken 8 as in question. 8 is in question. The factor of 8 is 1. The factor of 8 is 2. The factor of 8 is 4. The factor of 8 is 6. No. The factor of 8 is 8. The factor of 8 is 8. How many factors of 8 are there? There are 1, 2, 3, 4 factors of 8 in this particular table. In this particular table, 1, 2, 4 and 8 are the factors of, and I can prove it to you like this. 2, 8. 2 4 times, 2 2 times, 2 1 times. You see that these are the factors. These are the factors 1, 2, 4, 8, 1, 2, 4, 8. Okay. Now, the factors of 8 are, now let me only take these frequencies. Now, this frequency is 33, this frequency is 38, 4 is 35, and 8 is 35. Again, okay, 35, 35. Now we'll add all these frequencies. We'll add all these frequencies, and by adding we'll get, now these is 70, 105, 6, 7, 8, 33 plus 38 plus 70, 141. Now probability of factors of 8 is equal to, factors of 8 is equal to 141 divided by 260. Question 3 is, a consumer organization commissioned a series of tests to work the average lifetime of new brand of solar lamps. The result of the test is summarized in the table. Okay, again table is given. We'll often see some tables in statistics, in probability. Now let me complete the table, then I'll come again. Okay, now this is a table which is given to you. Now this table shows that lifetime of a bulb or a solar lamp is less than L. Now 0 is less than L or is equal to L. It is LRs, and L is less than 1000, 30 bulbs, and 1000 is less than L, and now this is Rs. Okay, L are Rs, 1000 Rs, and it is less than 2000, 75 bulbs, 2000 less than equal to L, which is also less than 3000, and 3000 is less than, there are 35. Okay, now this has the test and which has been summarized in this table. Now a consumer organization test of average lifetime now. Okay, now this is the average lifetime. Now what we have to do is calculate the relative frequency of the lamp lasting for less than 3000 hours but more than 1000 hours. Less than 3000 hours but more than 1000 hours. Now my dear students, this is the table which is given to you. Now what is in this table? The lifetime of lamp LRs and the frequency is like this, that this will last this is last this will, and you are able to that from 0 to 1000 it is from, and up from 1001 or from 1000 to, let us say, 2000 is 75. So this is the given, and what is asked here is calculate the relative frequency. Now we have to find the relative frequency of what, of what for lasting less than 3000 hours, less than 3000 hours. Relative frequency less than 3000 hours but more than 1000 hours, 1000 hours. Okay, I want to know about the frequency of bulbs lasting less than 3000 hours but more than 1000 hours. Here I am going to check where my relative frequency appears. Now here it does not. Okay, because it is from 0 to 1000. We want to pick the frequency above 1000, more than 1000. It is less than 1000. You see, it is less than 1000. So we'll come over here. You see that this is also less than 1000 but is also equals to 1000. Here the sign is like this. The sign over here is like this, which means it is less than, it is also less than 1000 but is also equal to 1000. It is also equal to 1000. So that means our frequency, this will be considered because this is L is also less than 2000 and more than. So it is more than. Now it clearly states that it is L is greater. If I read it from here side, this side from right side, the L is greater than or equal to 1000. It is greater than or equal to 1000. So it's 75. So 75 will be taken in consideration. Now 75 is taken in consideration, and similarly less than 3000. So it is less than 3000. You see, this is less than 3000 and is equal to, and is it also equal to 3000. So we cannot take this as because this is equal to 3000. We are going to consider only which are less than 3000. Now you see here the sign is L is less than 3000. So again this 160 will be considered. So it will be 235. Now the total frequency has come up to, the relative frequency will be of, what is this? This is P of this is equal to, because this is the relative frequency and it will become 235 divided by how much were there? There were 300 bulbs. Okay. Okay. Now this is your frequency, relative frequency. This is the relative frequency. 235 divided by 300, and when you see it is the relative frequency, you will calculate this, and it will become as point some 79 something like this, 0.783. The relative frequency is equal to RF is equal to 0.783 of this, that it will be less than 3000 hours or more than 1000 hours. Okay, now the second part of it. If the hardware chain ordered 2000 of these lamps, how many would you expect for less than more than 3000 hours? More than 3000 hours. You see that if he orders how many more than 3000 hours are, now you see that L is more than 3000 hours. This is 35 out of 300. 35 out of 300. Part B of the same question. Now if a hardware store, you see, if a hardware store 2000 of these lamps, 2000 lamps. Now what is the probability that it will last more than 3000? More than 3000. Now the category falls over here. Now the category falls over here because he said that it will last more than 3000. L is more than 3000 and the frequency is 35. Now 35 is the frequency of the bulbs within 300 bulbs. Okay, within 300 bulbs. And how many does he wants? He wants 2000 lamps. He wants 2000 lamps. It is very simple. You just uh, do it like this, and the answer will become 233.33. And ignoring this 33, you get only 203 possible bulbs which will be more than 3000 hours, which will be more than 200 uh, 3000 hours. Okay, so it's time to say you goodbye. Allah Hafiz.